Hi, my name is Kiara, and today we're going to be doing Exam 1 Solutions Part 3. Part A is going to ask us for a solid compound that dissolves in water, a liquid compound that dissolves in water, and a compound that dissolves in pentane. So first we need to know all the intermolecular forces that water contains, which is hydrogen bonding, dipole-dipole, and dispersion forces. So, we need to give an example of a solid compound that dissociates in water. So let's think about our ions. Specifically, group 1A, we have K plus and A plus. And we also have our ions and our anions and our cations. We have Br minus, Cl minus, and I minus. So, let's say we have KBr, potassium bromide. We know that this solid fully dissociates in water due to its ion dipole forces, dissociating with its K plus and its Br minus. So, we can put that as an example for a solid compound that dissociates in water. For a liquid compound that dissolves in water, we can think about our alcohols, such as ethanol and methanol. For this example, I'm going to use ethanol. Ethanol contains the same intermolecular forces as water: hydrogen bonding, dipole-dipole, and dispersion forces. Therefore, we can say that ethanol dissolves in water because it has the same intermolecular forces as water. For our third example, we need to find a compound that dissolves in pentane. Pentane is a little different. It contains hydrocarbons, and it only has one intermolecular force, which is dispersion forces. So, when I think of pentane, I think of all the other compounds that end in A-N-E, entane. And I'm going to say hectane can be an example because it also contains hydrocarbons and it only has dispersion forces. So, I'm going to say that hectane dissolves in pentane because it has the same intermolecular forces as pentane, which is dispersion forces. Lastly, for part A, we're asked to give an example of a solvent-solute that is greater than a solvent-solvent interaction, and a solvent-solute that is less than a solvent-solvent interaction. So, for a solvent-solute interaction that is greater than a solvent-solvent interaction, we know that a solution will form and fully dissociate. So, when we think about fully dissociating, let's think about ions. So, our ions dissociate in our plus and minus, our cations and our anions. So, I'm going to say NaI, sodium iodide, in water will be stronger because it contains ion dipole forces, and water only contains hydrogen bonding, dispersion forces, and dipole-dipole forces. Therefore, sodium iodide will be stronger and a solution will form. In a solvent-solute being less than a solvent-solvent, a solution does not form. An example of this is water and heptane. Heptane only has dispersion forces. Therefore, it will not dissociate in water because water contains hydrogen bonding, dispersion forces, and dipole-dipole forces. So because they don't have the same intermolecular forces, they will not be able to form a solution. All in all, for a solutions problem, make sure you understand that. You know all the intermolecular forces, and you know which ones are stronger and which ones are weaker. For example, ion dipole forces are way stronger than hydrogen bonding, and dispersion forces are weaker than hydrogen bonding, dipole-dipole, and ion dipole forces. Also, when we think about dissociating, think about ions, our cations and our anions. And we want to make sure that we remember solutions will form and fully dissociate when we have an ion dipole force molecule. And the solution will not form when we have a molecule that only contains the weakest force, such as dispersion forces, when it comes to water, which has hydrogen bonding, dispersion forces, and dipole-dipole forces.